can't see anything.
All right, everyone. Hope y'all had a good weekend. Couple of administrative things. This Thursday, my wife is going to be having surgery, and it's going to be early in the morning. She's supposed to be there overnight. I'm not sure how it's all going to work out. My plan is to be here at 1 o'clock, to teach class, and then to leave. So I won't hold office hours on Thursday morning, and then I'll come to class. Now, what I'd like for you to do is please check your Canvas email. If something happens where I'm not going to be here, I will let you know by 11 a.m. All right? Is that enough heads up time for everyone? Yes. Okay. So check your email. If you don't hear anything, then we're having class. All right?
This Thursday or next Thursday?
This Thursday. Yep. And then Friday of this week, I won't be on campus. So just so you know. Okay, and then also I'm passing around the quizzes from last week. And then I got booed as soon as I came in class today because I said there's not a quiz to start class. So there's no quiz, sorry. But we will have a quiz at the end of class, a group quiz, and it'll just be over what we do today. So you'll be able to work together, and it should just be a pretty easy grade. Yes? Exam 1 is a week from today. So if for some reason I have to cancel class Thursday, we will push the exam, all right? If I'm here Thursday, we'll talk more about it. But for you, what you should probably be doing is reviewing your homework at this point, because on Thursday, even if we have class, I'm not going to hand out a review. Okay? Pardon?
Bring it up with the types of problems.
What I'll do is I'll kind of tell you what to emphasize your studying on. Okay? Yes?
So, if I'm not mistaken, a week from now,
That's right.
So, in case there's no class on Thursday, so if you want to go over section 1.3, 1.4, 1.6, 1.5.
I just said a second ago that if I don't have class Thursday, we'll push the exam one day, so you don't have to worry about it. If we have class Thursday, I'll talk more about the exam on Thursday. Okay? All right, so we're going to get down to business. Y'all ready? Okay, so what I wanted to do to start off today is kind of summarize what we were talking about at the end of class last time, because it's really the fundamental idea behind at least a huge chunk of this class. And that is, if you have any function, right? Take any function where, I'm going to give you a couple of examples. Let's say this is time measured on your x-axis, and let's say over here, this is the temperature of something. So maybe you're measuring the temperature. You go put a thermometer in a car, right? Middle of summer in San Antonio, and close the doors and start measuring the temperature in the car, right? So you're going to have, the temperature that you start at, and then, I don't know, it's going to go up and then do something like that, maybe. All right, so if we wanted to look at the average rate of change in the temperature, what we would have to do to find the average rate of change in the temperature would be to pick 2 points and then find the average on that interval. So I could pick any 2 points in time. Let's say I pick this point, I'll call that T1. I'll call this point here T2. And then I'd find the temperature at T1, I find the temperature at T2, and then I would draw a straight line between them. We call that the secant line, right, from last class. And the slope of this line, which we know is rise over run, would give us that average rate of change. Average rate change of the temperature, right? That's the average rate of change of the temperature with respect to time. And then we could construct a little triangle, right? Rise would be how much our change is this way, right? Normally we call that like change in y, the change in the y coordinates, and this is the change in x. So one notation that we can use is this. That's our delta symbol that's used a lot in physics. Sorry, that should be delta y. Delta y. And this distance from here to here would be our delta x. Okay? So the change in y here is some quantity, right? And most importantly here is that the change of x, the change in x is some number, right? It's not 0. It's not 0, why?
Because then it wouldn't be a function.
We wouldn't be talking about 2 points, would we? Right? And we wouldn't be trying to find the average rate of change. So when you're talking about average rates of changes of things, this is all stuff that you did in college algebra. This is not what we're interested in this class at all. What we're interested in is same picture. Let's go temperature here. And let's go time here. Let's get that same basic picture here. Instead of saying, hey, let's find the average rate of change in temperature over some interval of time, you say, hey, look, let's go to exactly 1 point in time. Let's call it T1 again. And let's find the rate of change at that exact moment in time, right? So no longer an average rate of change. We want to know the slope of that tangent line. So the slope of this, okay, which again is going to be rise over run, will give us not the average rate of change, but what we call the instantaneous. The instantaneous rate of change. And what did we say is problematic about this?
There's no time. 0 over 0.
Yeah, there's no time, right? No time. You have basically no time elapses. So you have your delta x here is 0. And in fact, your delta y would also be 0 because if your x isn't changing, your y can't change. So how did we get around that? Yeah, we do a limit, right? So imagine that, we did this last class. We start sliding this point closer, right? Closer and closer. And when we get closer, our triangle changes, right? Each time we slide it, it changes. But our delta x starts to go to 0, doesn't it? So if we were to like zoom in and zoom in and zoom in and look at this little tiny little infinitesimal little triangle in here, it would look like this little tiny triangle. Now, these 2 points are they're like almost on top of one another. And when we're really close in taking a limit, looking in, then instead of using delta y and delta x, we use dy, and then here we use dx. And so with that sort of notation, then our rise over run would be our dy over dx. And we know that these are both approaching 0, right? These are both headed to 0, 0 over 0. But the limit allows us to get around 0 over 0, right? So algebra question, calculus, right? And these two quantities right here, temperature and time, can be any two quantities you want. You go to a chemistry class, this might be, I don't know, well, temperature and time is good for chemistry, right? Physics, it might be force and time. You go and look at a business class. This might be your, let's say, your profit over time. And it doesn't even have to be time. It can be something else, right? This can be some other variable. So anytime, ever, you ever want to know the instantaneous rate of change of a function, it's going to involve calculus, all right? Anytime you need to know how fast something is changing at an instant. With me? Okay, so what we did last time is we started to develop this idea, and let me bring up the notes where we left off. The way we did it to start is we said, okay, what we're going to do is we're going to first define the secant line, right? So we said we're going to pick some point A, and then we're going to pick some other point X. And then we're going to plug those into the function to get our 2 points. We draw our secant line, and then we slid that other point closer. And what was it? What was the actual calculus thing that slides that x closer? We have to take the limit as x approaches a. And so what we had was a formula for the slope of the tangent line to a curve. Tangent line. Tangent, instantaneous, right? That's what you should be thinking. So this slope of this tangent line is the limit as x approached a of this rise over run. Okay? And that's where we kind of left off. And so what we want to do now is apply this to an example. We're going to take a function. We're going to see if we can't find the instantaneous rate of change of that function at a specific point. All right, so here we go. I'm going to write down that definition over here. The slope of the tangent line, little subscript, I'll put tan. Slope of tan is the limit as x approaches a of f of x minus f of a all over x minus a. The sooner you memorize that, the easier your life's going to be. All right? So let's do an example. Find the slope of the tangent line to the curve f of x. And now this can be any curve, right? This can be any curve. So we're going to start out with a nice one. We're going to do a nice little polynomial function. Let's do x squared minus 3x plus 2. All right? And let's do it. Now, I'm asking us to find the slope of the tangent line to this curve. I actually have to tell you where I want you to look, right? Like where on that curve are we trying to find the tangent line? So I'm going to say at the point, and let's just go with 1. Let's see, 1. Is that right? 0? 1, 0. So 1, 0 does live on that curve, right? If I plug in 1 here for x, it's going to spit out 0. Okay, so that point 1, 0 lives on the curve. All right, so how do we do this? Well, let's identify, what is a for us? A is 1, okay? So a is always going to be the x coordinate right there. So if you want a quick little visualization of what's happening here, we have let me see, where this, it's going to be a parabola. It looks something like this. And we're looking at that point right there, and we're trying to find the slope of this tangent line that goes through like that. Okay, that's what we're trying to find. And so I need to know the x coordinate, right, of my, I like to call that a like my base point. That's where I'm basing everything at. So that's a is 1. And now we just go to this formula, right? That's it. So what we need to do is we need to calculate the slope of the tangent line, which will be the limit as x approaches what? 1, right, because a is 1, of f of x minus f of 1 over x minus 1. So all I'm doing here is rewriting the formula, replacing a with 1, right? All right, so now it's just, this part right here should look like something you did in college algebra, this difference quotient. So this will be equal to the limit as x approaches 1. Okay, f of x, which is just the function itself, right? And then I'm subtracting from that what? F of 1, which is what you get when you plug 1 into that, right? So we already know it's 0. How do we know it's 0? You can just plug it in, but how would we know it's 0 without even looking at this? Yeah, the point, right? Remember, this point lives on the curve, so this is the input and the output. So I already know this f of 1 is 0. And then all of this over what? X minus 1. Now, when we take this limit, what should we get? Like when we look at what this limit's doing, which is what you always do with all limits, right? You always see how it's behaving. We should get 0 over 0, shouldn't we? Because the whole idea is that this is the slope of the tangent line at a point. So we are going to get 0. And then we'll try and do some algebra to get around it. Any questions on the setup yet so far? So limit, you sure? No questions? X goes to 1. The numerator is just that. I don't need the 0. And then factor, right? We can factor the numerator. Okay, so this becomes limit. X approaches 1. The numerator factors x minus 2, x minus 1. All over x minus 1, like that. And then our factors cancel. And once they cancel, right, that took care of the 0 over 0. Now if I take the limit and I let x go to 1, what do I get? So these are gone, right? So if x goes to 1, I get 1 minus 2 is negative 1. So let's grab these sticks. Let's see. Oya? Oya? I'm thinking Oya may not be here anymore. Salo. Okay, Salo. I just have a quick question. What does this number represent? Like, give me. You're trying to explain this to me like I'm 10 years old. Like, what does that negative 1 represent to us? It's not a y value. What is this? Let's go back. What is this? This is this, right? So what is that? We're saying this is negative 1, but what is that? The slope of the tangent line, right? So in this picture, the negative 1 represents the slope of that line, right? And the fact that it's negative matches up with the picture, doesn't it? Negative 1 is saying that's the pitch of that line, okay? All right, everyone good with this? Okay, now I'm going to add another part to this. So I wanted you to find the slope of this, okay? Part B of this, I guess. Now, find the equation of the tangent line at that point 1, 0. So now I want the equation of the tangent line, not the slope, right? The slope's the slope. The equation of the tangent line is something else. So Danielle D. Danielle. No. Okay. See, I think Ian's not here, right? Ian? Yeah, he emailed me. Okay, David Garza. All right, David. Equation of the tangent line, right? Any ideas how to do this?
None that I can think of.
Okay, so in college algebra, to find the equation of a line, we either needed to have 2 points or we needed a point and a slope of the line. Which of those do we have? Do we have 2 points or do we have a point and a slope? Point, right? Slope, right? So if we have the point and we have the slope, we just use the point-slope formula. So using the point-slope formula, so using y minus y1 equals m times x minus x1, using that good old formula from college algebra, point-slope formula, all you have to do is replace your x1, y1 with the x1, y1 and replace the m with negative 1, right? So we go y take away what? 0, right? Equals the slope, which is negative 1, and then x minus 1. And now that is the equation of the tangent line. But I'm going to clean it up. I'm going to make it look a little different here. I'm just going to solve for y. So on the left side is just y. The right side I'm going to distribute the negative 1 through, and we should get negative x plus 1. There it is. And that's our equation of our tangent line, and this is written in what's called slope intercept form, which is y equals mx plus b. That's your standard slope intercept form, y equals mx plus b. That is written that way. Okay? So now I'm going to test to see whether or not we did this correctly. So what I'm going to do, I'm going to go back here. I get tired of looking backwards. I'm going to just go to my graphing utility here. Maybe. Okay, I'm going to graph the curve, x squared minus 3x plus 2. Okay, y'all see my the parabola. And now I'm going to graph the line, right? I'm going to graph the line, which is this one right here. Y equals negative x plus 1. And who wants to volunteer to tell me what should happen when I graph this line? Who wants to tell me what we're going to see? It should be what? It should show the tangent where? Over here? Over here? Where? Yeah, so what we should see is a line passing through our graph at the point 1, 0, and it should be tangent to the curve. That's what we should see, right? If we see anything else, we've done something wrong.
So it doesn't matter about 1, 0 isn't on our graph?
1, 0 is on our graph. Yeah, 1, 0 is right there, right? So let's see. What was it again? Negative x plus 1? There it is. So do we all agree that that seems like a reasonable tangent line? That if I were to grab another point over here, draw a secant line, and then start dragging that point over here, that the slope, so I'm gonna fix this right here. I'm gonna grab another point here and start sliding it. Y'all agree that that tangent line, it's gonna be headed towards that one? That blue one is the best answer we could ever get? Okay. All right. So what is the instantaneous rate of change of this function at the point 1, 0? Negative 1. The instantaneous rate of change of this function at the point 1, 0 is negative 1. Okay? So the rate of change is always the slope. The equation is of the equation that this line right here is just representing the visualization of that line. That's it. All right. Does that seem somewhat straightforward? Okay, let's do something else. Let's take the same function, different point. Let's go at the different point. 1, 0 was too easy. All right, so I'm going to say this. So we want, here are the instructions. Find equation of tangent line of that function at x equals negative 2. Okay, so what's the difference between this problem and the previous one? What's different? Okay, so I didn't give you a point, did I? What did I give you, though? I gave you the x, and the x is the a, right? So that's still enough for us to do the problem. All we ever needed to know was that base point, right? Okay, so we can still do it. And other than that, the only other difference is that I'm not asking for the slope of the tangent line, am I? Asking for the equation. But to get the equation, you're going to still need the slope, right? So kind of like two birds with one stone here. All right, so let's start by identifying what a is. A here is negative 2, right? And now let's go and find the slope of the tangent line. Slope of the tangent line is going to be the limit as x approaches what? Negative 2 of the function, right? F of x. So we just write out the function, x squared minus 3x plus 2. Okay, Jesse? Where's Jesse? Jesse. Okay, so what comes after that? X squared minus 3x plus 2.
First step is canceling, like seeing what happens if
I can't hear you, I'm sorry.
seeing what happens when x is negative 2.
That's right. So we need to still figure out what this part is right here, right? So we're going to subtract whatever you get when you plug negative 2 into the function. So this part's going to be whatever we get when we plug negative 2 into the function. And what do we get? Let's see. 4, right?
Negative 12.
Plus 6 plus 2, right? So what is that? So, but this would be 12, right? So what I'm going to do is I'm going to leave this minus here, and I'm just going to put 12 in here. And you'll see why later, because later on, this minus will have to distribute through to things. So I'm just going to write that out like that, Okay, so it will become minus 12, just not yet. That all right? Now all over what? X minus negative 2, which is really going to become x plus 2. All right. All right, so limit x approaches negative 2. All right. In the numerator, we should have x squared minus 3x, and then what? We can go ahead and do that 2 take away 12 now, right? So minus 10. And on the bottom, x plus 2. Now, if we take this limit right now, what should we get? We should get 0 over 0. Shall we check real quick? Negative 2 goes in here. Negative 2, that's a 4. 3 times negative 2 is negative 6, but then changes, so that's going to be plus 6. So you get 4 plus 6, that's 10. 10 take away 10. 0 on top, 0 on the bottom. So we have a problem. So we do some algebra. And this one factors again, right? So limit x approaches negative 2. I am recording. Yes, my microphone is on. Okay. And then we factor. What does that factor to be up top? X minus 5, x plus 2. And the x plus 2s are going to cancel. And now we can let x go to negative 2. And what do we get? Negative 7. The slope of our tangent line is negative 7, right? Okay, Arturo. I have the slope, right? Okay, so now you ready for the equation? Okay, so going to use that same formula, right? Y minus y1 equals m times x minus x1. So I'm just going to let you tell me what goes where. Y minus what? Okay, so what is y1 for us? It's not given, right? Okay, so let's skip it for a second. Okay, equals, let's see, what's our slope? Negative 7. And then x minus, do we know x1? What's x1? Negative 2. Okay. So remember, this point, x1, y1, in the previous problem, I gave you that, right? And this one, I only gave you this, right? So you would have to figure out what's the output when you plug in that number, right? Didn't we do that already? We did it, right? At this point right here, at this place. So it's the 12. Okay? So y minus 12. Just going to clean it up a little bit and get it in slope-intercept form. Distribute the negative 7. Last step. Add 12. There it is. That is the slope-intercept form of the line that should be tangent to our curve, passing through our curve at the point what? Negative 212, right? So if I bring that graph back up, we look at negative 212 on the graph. It should be there, right? Did I leave it there? Going to have to zoom out a little bit here. So I'm just going to, our line was negative 7x minus 2. There it is. Do y'all see it right there? Negative 212 passes through there. Do you believe it's tangent? We'd have to zoom in, right? Wait, where'd the other one go? Can't even see the two anymore. But do y'all believe it or not? Did we find it? Yeah? Okay. So what do you think happens now? I mean, now that we have like a fundamental idea of what's going on, I think we do. What do you think's about to change? This is going to change, right? This was easy to work with, right? So now the functions get harder. And pretty much in calculus, anything's on the table. We're not stuck in like, has to be polynomials, has to be rational functions, has to be this. We want to be able to do tangent lines for any function anyone ever gives us. All right? Which is going to be a major problem, all right? It's going to be a major problem. But that's why we're here, right? All right, so let's do another one. How about find the equation of the tangent line to the function f of x equals x plus 3 over 2x minus 1 at x equals 5. I would get used to me not giving you the point, like the x and y coordinate. The book likes to give you both of them, but I don't like to give my students both because I want everyone to understand that you can get the y coordinate. If you have the x coordinate, you could always get the y, all right? So that's it right there. So what are we going to start with? Right here, right? We want to do this. Let's go to the definition. So the slope of our tangent line should be the limit x approaches what? 5. This time I'll write it down. F of x minus f of 5 over x minus 5. So that's just me replacing a with 5 in the formula.
Professor,
Yes?
so when you say the limit of sub tan, like, or is it m sub tan, that's considered, like, you're going to look for that notation?
Do I want that notation from you?
Okay, specific.
You don't need to. You don't have to put m tan. It's just, when you talk about the slope of a line, you could be talking about the slope of the line through 2 points on the curve, which would make it a secant line. But this is a very special line. It's the tangent. So we just want to, illustrate somewhere in our notation that we're talking about something that passes through the function at 1 point. But not necessary. It still is just the slope of a line. I mean, right? It still is just slope of a line. All right. James.
Yes.
Look, I scrambled these up, right? And I've called everyone at the table in a row. No, I think we had one. That's kind of odd. All right, well, you're up. So rewrite the limit. Do you think I care whether or not you write the limit each time? Yes, I do care. All right. So don't get in the habit of just trying to do all this algebra and then, put your limit in when you want it. I mean, this all has to flow line to line. Okay, so what should I write next?
X plus 3
Okay, x plus 3 over 2x minus 1. Okay, and then I'm going to do minus, now f of 5. Have you figured out what f of 5 is yet? 8 over 9. 8 ninths. So I'm just going to write it as a fraction, 8 ninths. Right, that's what it is. All that over x minus 5. All right, so right now, if you tried to let x go to 5, you should get 0 over 0. That's what should happen. So we already know we have to do some algebra. So what algebra, James, do you want to keep going?
Sure.
What algebra do you want to do to kind of try and attack that thing?
Well, the first thing I'm going to do is just take common denominator.
So put these two fractions together, okay? So that's kind of the standard technique when you have a complex fraction, fractions within fractions. Combine the numerator together. So multiply top and bottom here by 9, right? Something like that. And then multiply top and bottom here by what? 2x minus 1. 2x minus 1. All right, and just be careful because this 9 must distribute through, right? That 9, I can distribute it or I can leave it out front. It's really up to us because it's the same thing over here. So you want me to distribute the 9 on the bottom or leave it, James? Pardon?
Leave it for now.
Leave it for now? Okay, so I will have to distribute the top. 9x plus 27 over, you said leave the bottom, 9 times 2x minus 1 minus 16x minus 8 over 9 times 2x minus 1. All of that over x minus 5. I do that right, James? Is that the way you would have done it all in one step? Yeah, me too, but I'm illustrating it for everyone. So Okay, so now combine them. So what happens, James, when you combine these? We have to be real careful with that minus, don't we, everyone? That minus has to go here and here. So that negative 8 becomes a plus. So James, what do you got up top when you combine it all?
9x plus 27 minus 16x plus 8 over 9 times.
Okay, so what is that? What you just said the top would be. So combine them.
All right. 25x.
We're subtracting, careful.
Oh, yeah, subtract. Go on.
It's got to be negative, right? 7x, and then plus, we're adding 8, right?
Yeah.
Okay, 35. All over. It's different when you're on the spot, right? All over x minus 5. So look at this. We have fraction over this, right? Remember I've talked about how important this long division bar is compared to the short one, right? Because what that's going to allow us to do is flip this if we need to. And I think we need to. Does anything get better here? Do y'all see that anything actually...
We can actually take out the 7.
That's so in the numerator of the fraction over there, if we take a 7 out, we'll be left with negative x plus 5, right? Which is almost this. So let's factor out what from the top there.
You factor in actually both, right? The negative and the 7.
I didn't hear it. What?
Can we factor out the both, the negative and the 7?
Yes, that's exactly what I would do. Negative 7, pull that out of the top. And if you pull the negative 7 out, then that's going to be x minus 5. And that's what you want, right? Because it's going to cancel with the bottom one. And then 9 times 2x minus 1, and then all of this over x minus 5. And you know, when I was in Cal 1, maybe my algebra wasn't that great or I didn't feel comfortable with it. Like, I knew that these would cancel, okay? But I wasn't completely sure why they canceled. So just everyone be sure it's because this is over 1, and then you multiply by the reciprocal. This becomes 1 over x minus 5, right? That's no longer there. And then they're gone, okay? That's the mechanics behind what's happening. You don't have to show that, just make sure you cancel the right things, all right? All right, what is still here? Let's see. We're moving on to someone else now, James. Herman.
Yeah.
Herman? Okay, Herman, what's left? What have I got left here?
It should be negative 7
Negative 7 over 9
times 2x minus 1.
2x minus 1, like that. Okay? That's what we have. And now when we take the limit, we should no longer get 0 over 0. So Herman, what do we get when we take the limit? And I'm not going to write limit anymore because we're about to take the limit, right? So I finally get to stop writing it. So Herman, what do we get?
It should be negative 7
Negative 7
over 9 times t times 5. 2 times 5 is 10. Should be 90 minus 1.
9 times, yeah. Nope. That's 10 minus 1, that's 9, right? 9 times 9.
Yeah.
81. There it is. Herman, what is this number representative of?
Should be m.
Okay, which is the tangent, the slope of the tangent line to this function where?
What do you mean?
Like where? Just randomly anywhere on the graph that slopes that? Or is it, it's only at one place, right? That it's actually this slope? So this right here is the slope of your tangent line to this curve at what point? At what point is that the slope?
Should be
What was the x? The x was
5.
5.
Should be y.
What was the y? We got it way back when we did this, right? That right there was that number 8/9. So if you go and you graph that function, which I've erased, what is it? X plus 3 over 2x minus 1. If we go graph this function, and we go out to the point 5/8, which should live on the graph, and we draw the tangent line, it should have this slope, okay? Herman, does that all make sense? All
Yeah.
connecting it all together?
Is it gonna be 8, negative 8 over 9? or
Nope,
is it
it's
8?
positive. This is from the formula. This minus came from the formula. It is not the f of a. F of 5 came out to be 8/9. All right, have we answered the question? We're on our way. We're not there yet, right? So now we gotta finish it up because I wanted the equation. Not the slope of the tangent line, the equation of the tangent line. So on an exam or a quiz, if I ask you for the equation of the tangent line and you give me just the slope, it's not correct, right? You've only answered part of it. Now, I mean, and the sad thing is if you stop there, it's not a whole lot of work to get the rest of it, right? You just have to use the formula y minus y1 equals m times x minus x1. Which David M. David, help me plug all the stuff in for this. Y minus 8 over 9 equals negative 7 over 81
Times x minus 5.
x minus 5. Everyone got that? Now, I would like this in slope-intercept form. So we got to solve for y. So your numbers are going to suck, but you know, it's life. Okay, it's the way it goes. Negative 7 over 81x, that's distributing. And the next one should be plus 35 over 81, distributing. And then let's add 8/9 to both sides. Adding 8/9, so you'll have to get a common denominator between these two, right? So that means you're multiply top and bottom of that one by 9, so this will be 72 over 81. And when you add those up, what was it, 105? 107. Why did I say, yeah, okay, 107. 107 over 81. There you go. Y equals. Every answer we get should be a line. Every answer we get should be a line. I'm curious to see if we got it right. I mean, I know we got it right, but I'm curious to see it. Okay, so it was, I forgot. What was it? X plus 3 over 2x minus 1. And whoa, that's pretty interesting looking. And we were at the point 5, oops, wrong way. 5, which is, here's 5. Let me zoom in a little bit more. There's 5. We'll move it over here so you can see it. Okay, so there's 5, right? If you go up, that's 8/9. And when I graph this line, it's a very strange line. Negative 7 over 81x. Not there yet. Plus 107 over 81. There it is. Right through that point. Tangent, right? It's tangent. Looks good. I'll zoom out a little bit so we can just really agree that that is a tangent line. There we go. Okay. Find the equation on the tangent line to this function, f of x equals 1 over the square root of 4x plus 3 at, let's make it 4x plus, well, you know what? No, I'm not going to make it nice. At x equals 2. All right, Jackson's up. Where are we starting at here, Jackson?
First you have to plug it into the formula.
Plug it in here. So tangent formula, limit. Where are we approaching, Jackson?
X approaches 2.
X approaches 2.
It's 1 over the square root of 4x plus 3.
Okay.
Minus 1 over the square root of 8 plus 3 is 11.
Square root of 11. Everyone agree?
All over
All over
x minus 2.
x minus 2. Everyone understand where all that came from? Okay. And Jackson, if we take the limit right now, we're going to get what?
0.
0 over 0, right? So we know, as long as we wrote everything down correctly, we should get 0 over 0. All right, so any ideas, Jackson, how we could go about cleaning that one up?
You could try getting a common denominator.
Common denominator. So again, push them together, right? So what would I have to introduce to this one here?
You have to multiply by radical 11 over
Root 11 over root 11.
and then by radical 4x plus 3.
Yeah.
Over radical 4x plus 3.
All right. Okay, everyone agree? That should get us common denominator, should be able to push these together. You want to keep going?
Sure.
Okay.
So that gives you, on the top in the numerator, it'll give you radical 11
Root 11.
over, would it be radical 44x plus 33?
You could put that radical together and put the 11 inside, or you could leave it outside. It really doesn't matter. So, but yes, if you did it, if you wanted to push that in there, here's how this would work. You did it, you said it correctly, but just so everyone's with you. If you have two things being multiplied under a root, you can put it all under one root and then multiply the two. So this is a property of radicals. So this would become 44x minus plus 33 if you wanted it all together, which you said we could do it. Let's just do it. All right. So do you want me to do these separately, or do you want to combine them now?
Just combine.
Combine them. Okay. So it would be root 11 and then what?
Minus radical 4x plus 3.
4x plus 3
All over root 44x plus 33.
plus 33, and then all of that over
X minus 2.
x minus 2. And at this point, we should still get 0 over 0, right? We should still, because nothing has canceled. What we eventually need is for this x minus 2 to cancel. So I like the common denominator. Let's move on. Elijah? Same table. This is weird. Okay, Elijah. Any ideas?
So do the reciprocal would.
You're saying like if you did that and flipped it up here, right? Then you would be looking for the x minus 2 to somehow cancel. I don't see an x minus 2, do you? Okay, so when you were doing limits and you saw radicals like this, roots, what was one of the things that we kind of thought maybe would be in our arsenal? So we can't square it, but there's something we could do over here. Top and bottom, multiply by something, the conjugate. Okay, good. So the conjugate of what though? The conjugate of,
Radical 44
not this one,
on top.
on this, because we want this to cancel, right? So whatever we want to cancel is going to have to come from here.
Radical 11 plus.
There we go. So everyone, y'all good with that? We're going to come in with the conjugate because we see radicals. And really, we're stuck at this point. So here's what I'm going to do. I'm going to take that, multiply this by the conjugate, which is root 11 plus square root of 4x plus 3, and then divide that by root 11 plus root 4x plus 3. There's our conjugate. Now when we do that, Elijah, the top should get better, right? I mean, it should get better. The middle terms, right? It should be gone, no more radicals. So let's go ahead and do it. When we go here to here, we're foiling, right? Here to here, just 11. So we get 11. The middle terms we're not even going to look at, right? So it's just the outer ones, or yeah, these two outside ones. This times this. Now take your time here. Be very careful here. Are you going to have a positive or a negative? when you do this times this? Negative, right? Okay. And then the radicals will cancel each other out, right? So you'll just have what's underneath them, which is 4x plus 3, right? But don't forget that minus. So you have to put 4x plus 3 in parentheses. That negative will go through. Is everyone clear on that? Now, what is that still on top of? This nasty looking denominator. And it's nasty, right? It's this times this, right? We have been getting away with not having to actually multiply those together, right? So let's not do that. Okay, let's just leave it as this root 44x plus 33 times, in parentheses, root 11 plus root 4x plus 3. Okay, isn't that what this times this is? I just haven't actually multiplied, I just wrote them next to each other. And then all of that is over, bigger division bar, x minus 2. All right. And we keep going. Nobody. It's blank. I don't know where that came from. These are all blank. No. There we go. Yusuf. You said that better, right?
Yeah.
All right. Are you okay with this so far?
Yeah.
Okay. So I just want you to clean up the numerator here for me. What does this new numerator turn into? And I'll put it right here.
Negative 4x.
Negative 4x plus 8 over that real crappy denominator, right? So crappy denominator is here, 44x plus 33, parenthesis, root 11 plus root 4x plus 3. Then all of that, forgot my parenthesis here, over x minus 2. And Yusuf, am I saying Seth or Sif? Yusuf. Okay, so Yusuf. I want you're trying to get this to cancel, right? I mean, that's like the thing. So can you somehow get that from that? Take out negative 4, right? Everyone see that? Let's just take a negative 4 out of the top. Take a negative 4 out of this, and we should have that. So I don't want to write this all again. So I'm just going to do that, and above it I'm put negative 4, and then x minus 2. And now you'll see that these two will cancel. Again, you could write that as this over 1 and then flip it, and then it would go away. So there's some good news here, okay? The good news is that if you do the correct algebra, you should always get something to cancel. Yes?
What? 11.
What 11? Oh, here.
Yeah.
This becomes 11 minus 4x minus 3. Distribute. And then 11 minus 3 is 8. All right. So that's good. Do you want to just tell me what the next line is going to be then? You can. We're almost there, right? Limit x approaches 2. Okay, what's my next line after some things cancel out?
It's going to be the square root of
All this, right?
Yeah.
Okay. Do we have anything left on top of it though?
Oh, what? Oh,
Negative 4, right? So we pulled that negative 4 out. It's still there on top. So we still have the negative 4 on top. And then we have all that nasty stuff. Square root of 44x plus 33 times, in parentheses, square root of 11 plus square root of 4x plus 3. Yeah, that's it. Now, when we take the limit, we should no longer get 0 over 0. In fact, what we do get, don't worry about it, just leave it. Jasmine, right? Jasmine, what do we get when we take that limit? So no more limit now, right? So what do we get? Negative 4 on top. All right, and you're replacing all your x's with 2's, right? So let's see here. Yeah. I think it's 113. Is it 113? Root?
Yeah, it's 121
wait, what? 88? Oh, 88. I don't know why I was thinking. I did 80. 121? And that happens to be 11, but we'll get to that in a minute. And then we have root 11, and then plus root 11. Okay. So this is 11, right? Square root of 121. So we have negative 4 over 11. And then if you take root 11 and you add another root 11, how many root 11s do you have? You have 2 root 11s. And now you can actually multiply this 2 and this 11 together to get 22. So we have negative 4 over 22 root 11. And that right there is good enough. We could rationalize this or... And what is that, Jasmine? What is that number representing to us? Slope of the tangent line to that curve at the point 2, I forgot. 1 was it? Was it 1 over? 1 over root 11. Okay. All right. Good. So now we're going to do the equation of the tangent line now. All we have is the slope. So the equation of the tangent line will be y minus y1 equals m times x minus x1. I'll take a moment to just recap what we have. M is that, negative 4 over 22 root 11. X1 is 2, and y1 was what we got when we plugged 2 in, which y'all are saying is 1 over root 11, right? That's kind of a recap of all the information we have. And now we just plug it in. Okay. Y minus 1 over root 11 equals negative 4 over 22 root 11 times x minus 2. And then you could distribute and move things over, right? Okay, so distribute y minus 1 over root 11 equals, when I distribute that through, oh, I could have reduced that fraction, huh? Oh, well, whatever. Negative 4 over 22 root 11 times x plus 8 over 22 root 11. So the 4 and the 2 come together, negative and negative is positive. And then I'm going to wind up adding a 1 over root 11 to that, aren't I? So I'm going to add 1 over root 11 to both sides, and that'll kill this one off. And then to put those two together, well, I don't know. Maybe I should reduce. Wait, is that what I heard?
Yeah, can't you cancel the, when I multiplied the negative 2 in the negative 4 over 22?
Cancel the 9? What?
No, the negative 2. Can't you cancel the 2 factor in the denominator?
Oh, I could have done the 4. That's what I'm saying. Like I should have reduced this a long time ago. But I'm going to do it at the very end. My final version is going to be completely cleaned up. Okay? So this right now, I reduced that, right? 2 went into both the 4 and the 22. And then here, I'm going to go ahead and do 2 into both of those. So 4 over 11 root 11 plus 1 over root 11, which is what you would have got, Jackson, had you canceled the 2 and the 22. And I still need to put these together. So how do you put those together? Common denominator, which means you have to multiply top and bottom of this one by 11, right? So you have to multiply 11 here, 11 here. So y equals negative 2 over 11 root 11 x. And how many of these are we going to have? Should be 11 of these, right? And there should be 4 of those. So 15 of them. We have 15 over 11 root 11. There it is. You could put it all in one. I'm going to leave it like this because it looks like y equals mx plus b. So it's just, all right, I'm ready to see if